Hello, everyone. My name's Courtney Brown, and I'm a marketing manager at Enterprise DB. I will be your host today for EDB and Vivid Cortex's webinar, Best Practices for Monitoring Postgres. I'm joined by Bhavani Rao, EDB's Senior Product Marketing Manager, as well as Vivid Cortex's Baron Schwartz, Founder and Chief Technology Officer. Before we get started, I just wanted to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for an hour. We expect the presentation to last most of our time today, but we'll allot any extra time for Q&A at the end. If we do not have time to address all questions, we'll follow up afterwards with any attendee whose question was not answered. And now it's time to hand it over to Bhavani and Baron.
Thank you, Courtney. So I'm really excited to be here today because we put together a very informative and educational webinar around monitoring databases and monitoring Postgres. So I think you're going to get a lot out of it. Real quickly, what we're going to cover today is a little bit about what are the benefits of database monitoring, why it's relevant, who needs to do it, who it's most beneficial for. And then we're going to take a look at the landscape of different tools out there in terms of what functions they offer and where you would be best suited in terms of your individual needs. And because of the fact that we have two experts on the call with our respective products, with regard to myself from Enterprise DB and Baron from Vivid Cortex, we know those products pretty well. We're not going to, endorse them 100%, but we're just going to talk to you a little bit about what the capabilities are and let you decide on your own what would be the best fit for you. And lastly, we have an offer that Baron will talk about in the very last slide. So let's get started. Just want to set a little bit of context here with regard to Postgres itself. For those of you who are still exploring Postgres as a viable option, I've got three different perspectives I want to share with you. One from, say, more of a, on the left column, more of a DBA-oriented perspective. A second one in the middle, more of a developer-oriented perspective. And lastly, the analyst perspective. And you can see here off these slides that Postgres is really hot. It's leading the pack in 2017, leading the pack in 2018. We expect the same in 2019. In the middle, we have a recent survey done by Stack Overflow. I'm sure many of you are familiar with that as a developer resource. And Postgres has recently moved up so that it's gone advanced ahead of MySQL. So in recent, I'm sorry, not MySQL, but SQL Server in recent survey results, to the point that a lot of people who are in the developer community who are very familiar with the LAMP stack, the Linux, Apache, MySQL, and PHP stack, are now considering the LAP stack, LAPPP, which would be Linux, Apache, Postgres, and PHP. And then lastly, we have an analyst quote talking about the fact that 70% of new in-house applications were developed on open source database management systems. So having said that, what's to be gained from monitoring? Why bother with monitoring to begin with? So we thought about this and we broke it down into high level and low level benefits. So the low level benefits is what's shown up on top. We have obviously you're going to be able to benefit from being able to get better utilization of time and resources if you do monitoring. That is, you have a lot of money invested in people as well as in hardware. So trying to understand your CPU utilization, if you have a cloud environment, whether you're getting, what am I getting for my value, my money there? And then if you have, looking at capacity planning, if you're looking at an application and it's eating up more and more disk space, do I have enough disk space? So you need to look into capacity planning and see if you can plan, manage for that. And availability, if you have a mission critical application, are my backups available? Are they concurrent? Is there any kind of latency issues I should be aware of if I'm running on a standby basis? Those are the type of things. And lastly, from a performance perspective, if you're an application developer, are my queries being resolved in seconds or milliseconds rather than taking multiple seconds? So those would be, we would consider those low-level benefits. And then the high-level benefits along the lines of the ultimate goal for many of us is trying to drive a better user experience. That is the main goal, because we are all trying to compete in the marketplace, try to deliver better than our competitors. and database plays a fundamental role in that. Additional benefits from a high-level basis would be along the lines of trying to manage our costs. I didn't say lowering our costs, but trying to manage our costs and anticipating what would be the best, utilization of our money. And then lastly, to avoid for any work stoppages, any downtime. So those are fundamental reasons on why monitoring is important. One thing I want to also drill down is the fact that databases are very different than typical applications. And this came pretty apparent to me very early on as I started working with databases, and that I'm a newcomer myself to databases. And unlike a lot of applications out there, when you look at, say, applications such as, say, a compiler or an operating system, or even say a CI/CD tool, those applications are very different because of the fact that in many ways you can restart them without any issues. And the reason for that is because they don't record the state. They transfer information about state or the different interactions they have with the user to a different layer, to a data layer, and that's usually the database. So the database is very different because it is stateful, unlike most other applications. And so it has to have that durability requirement. Secondly, unlike a lot of other applications out there, you can kind of estimate what the workloads can be. So for example, if you have a web server, you kind of know how many HTTP requests you're going to get based on different times of the month. You can map that all out with Google Analytics or something like that. But with a database, the variability of the workload is quite diverse. So you not only have your standard CRUD operations, but you could have different types of use cases like data warehouse, analytics, and then on top of that, you have variability based off of not only the types of workload, but also the time frames. So for example, your month-end type of transactions will be different than what you do in other parts of the month or different parts of the year. And then lastly, there's a dimension to databases that's fundamentally different than, say, other applications. And that is that unlike time series, a lot of applications collect time series information, but there's a secondary dimension to databases along the lines of going beyond just time series, along the lines of examining SQL statements, examining explain plans, etc. And at this point, I'd like to invite Baron to say a few words because I think he has something to say here.
Sure, yeah, thanks, Bhavani. Yeah, from my perspective as, historically a database administrator and developer and eventually building monitoring tools for databases, what I found was I got really poor results from using general purpose monitoring systems for databases. And as I got more knowledge and familiarity with databases, I started to understand why. Because, for example, databases are declared if you say, I would like this data, and then the database is supposed to figure out the optimal way to do it among many possible execution plans. And so there's, the database is making some decisions. It's not all in the hands of the developer. And that means that it can make wrong decisions. And when it does that, you have to be able to diagnose why and how. And, there are very many other things. That's like one example out of dozens that I could cite. But for diagnosing, debugging, and fixing all of those issues, you need more than just some metrics that are drawn on a chart. You need things like this rich blob of text that's your explain plan that tells you what the database was going to try and do. And you need to look at the SQL itself or whatever language, in this case, Postgres, it's SQL. And all of those things don't fit into traditional monitoring systems that just take numbers and timestamp them and write them into a time series data store. So there's a fundamental complexity in the database itself that has to be accommodated by the monitoring tools, or you just don't get the depth and richness that you need to make databases perform well.
Thanks, Baron. So when you think about that, from the perspective of people who are using databases, we broke down, the different areas that need to be monitored in 3 major categories. And this is our best understanding of how to break it down. So we broke it down in terms of looking at the actual operating system and the hardware, the Postgres server software itself, and then lastly, looking at the very highest level at the queries and the SQL. And each of these can then break down into individual components. So for example, at the OS level, you'd be looking at input output, your memory utilization, your network utilization, CPU, physical disk space, component status, all that kind of stuff. And at the database server level, you'd be looking at, say, your DML, DDL logs, wait time, users, objects, where the replication ran, whether the backups, how the replication is running, and if the backups ran at all. And lastly, at the SQL perspective, how are we doing with regard to throughput, latency, concurrency, and errors? Baron, do you have anything to add here?
Yeah, this is kind of a very succinct view of a monitoring philosophy that I've developed over some period of time. And I've given entire presentations about this and written about it pretty extensively in various books and things like that. It also comes from, for example, a lot of my view on monitoring comes from Kerry Millsap. And if you're not familiar with Kerry Millsap, his book, Optimizing Oracle Performance, is classic in the field. And so this kind of very simple 3-layer diagram actually maps to a philosophy of understanding what's happening in your systems, what matters, and how to monitor it. And at the end of the slideshow, I'll have a link to another presentation that I've given, which is also recorded, that people could click to if they want and watch that talk and read the slides. But just at a really high level, in the outer layer, we're looking at what users care about. And really, we've got a database to do work, useful things on the behalf of users, which means that we're actually answering requests from them. And so from the user's perspective, what they care about is, are you doing the work I ask of you? And are you doing it quickly and correctly? So if the database is doing those things, no matter what the CPU utilization is behind the scenes or whatever, then the database is doing its job as far as the user or the application or whatever is on the other side of that request is concerned. Internally, we have to figure out why or why not that's happening. And so we need to understand the inner workings of the database, which is very intricate, with all of these things like locking and buffer pools and so forth and so on. And if something isn't working, we need to understand why and fix it. And those are very common. There's what I call sharp corners that every database technology has. That's something that just kind of classically goes wrong. It's maybe misconfigured or it's vulnerable to certain kinds of edge conditions that cause it to misbehave or whatever. And you also have to understand the resources that the server, that the database itself, RDBMS, relies on to get that work done on behalf of the user. And so that is kind of your core fundamental building blocks of computation: CPU, storage, IO, things like that. So, Postgres can't do its work unless it has the operating system and the hardware to help it do that work. And so sometimes, Postgres is actually a victim of resource starvation or, broken RAID array or things like that. So that's why you have to look at the underlying resources as well. And again, all of this is kind of broken out in the slideshow that we'll link in the resources at the end.
Thanks, Baron. So another, given that there's a lot of things to monitor, we also try to break it down in terms of who is it relevant for, who cares about this kind of stuff. So we kind of broke it down into, say, 3 different roles along the lines of, say, operations, developers, and then database administrators. In some areas, database administrators are evolving, and sometimes a new role is called database reliability engineer, and sometimes a site reliability engineer. And sometimes in some DevOps teams, everybody's all in one. In any case, if you are in operations, the areas that you'd probably be, what's relevant for you would be looking in terms of trying to understand how is doing regular database monitoring, being able to administer a database in terms of new creating new tables, adding users, things of that nature. And from a developer perspective, as Baron had talked about, it's all along the user, which is, either creating new applications and being responsive to those applications, the client applications, or creating, some sort of database development, whether that's potentially a migration or working with an existing legacy app and making sure that we can have some sort of foreign data wrappers that work with that. And then lastly, the traditional database administrator role will include just about everything, which would be being able to do monitoring, administration, as well as any kind of development work on the database itself. So given that we've talked a little bit about, what are the benefits of monitoring, who's involved in who would benefit from monitoring, as well as, the different areas to monitor, these are the most common questions that come up. this is a sampling of of some of the questions that come up. Things such as, from a DBA perspective, did the backup complete successfully? From a developer perspective, which, maybe the DBA would be more concerned about which queries are consuming the most resources. Same thing with, is replication running and up to date? And then the developer will be concerned about, is my app encountering slow queries sometimes? And another common one in the Postgres world is, did the auto vacuum run or not? Are the databases bloated? Are the configuration settings optimal? And then from a planning perspective, when will we run out of disk space? And then from a disk administrative perspective, who actually has access to this database, and what's the schema that we've applied to it? So these are just a sampling of the questions. And then what we're going to do here is going to ask you a survey question right now.
Great, thank you, Bhavani. I am going to launch our survey question. So our quick poll is, what monitoring tools are you using now or thinking of using? You can select any that apply. So we have our results coming through.
Can you read off the choices?
Yep, the choices are Datadog, EDB Postgres Enterprise Manager, Nagios, Vivid Cortex, or other. So as our results are coming in, we're seeing about half of the audience saying other. Probably about 28% are using PEM. 5% using Vivid Cortex. Okay, I think we have most of our answers trickling in, so I will close the poll.
Yeah, that's fine. Thank you for the poll question there. So it's good to see that there's a diverse variety of choices, and this particular presentation is apropos for that discussion, because what we're going to talk about is the landscape of tools at this point, and then Baron's going to drill down into each of the different tools. So when we started looking, myself and Baron started looking at the different tools out there, there's so many different ways of dissecting, which tools do what and what would be beneficial based off of an individual customer's needs. So we broke it down into 4 categories, and those categories being able to do in the top left quadrant, starting with health checks / alerting, and then another one being being able to optimize query performance. And then in the bottom left here, we have administration or reporting. And lastly, we have a category that we just kind of bucketed all the ones that did a little bit of everything into, which would be general purpose monitoring. And so what we want to say here is that the best way to look at these tools is to try to understand what your needs are. Are my needs more along the lines of alerting or performance or reporting, et cetera? And based off of that, that would be guiding you as to what would be the most optimal choice. And so, having said that, we did take a look at some of the more popular choices out there, and that's what I'm presenting in this next slide, is talking about the different tools out there and trying to categorize them. And for the purposes of the discussion here, I'm just gonna, this is a subjective assessment of placement of these different tools. I'm sure that your analysis and you might have come up to a different conclusion, but this is just a way to facilitate today's discussion. One thing I do want to highlight is that we have Enterprise DB has a tool. Some of you are familiar with it as Postgres Enterprise Manager, and we put it in a straddling position. So it actually does alerting as well as administration, and it does a little bit of query performance. I couldn't figure out how to make that happen here. And then Vivid Cortex, which is the tool that Baron's going to talk about later today, is squarely in the in the query performance section. So I believe at this point we're going to have one more. Okay, so we're going to talk into. I think we might have lost a survey question, but maybe not. Anyway, I'm going to have Baron go ahead, run through these slides.
Sure, thanks. So for each of those categories, and by the way, there's no judgment about which tools are better. Like that chart doesn't represent that the sort of forest or waves chart or anything like that. It's just really a category. So the placement isn't significant. It doesn't represent any value judgment or anything like that. And there are also other tools that we're probably missing. Hopefully folks will forgive us for any important tools that we've missed in there, but hopefully it's a representative sample. So let me just talk through why there's such a great diversity and what each of these categories can do for us. And hopefully it'll be evident, why databases require 4 different categories of monitoring tools, in order to do everything. So let's go ahead to the health checks and alerting, and I'll start there. So the health checks and alerting, I think the granddaddy of them, there are probably folks who remember the great granddaddy, but for most of us in the field today, the granddaddy of them is Nagios. And Nagios has these little plugins that'll just run some check. It's basically a script that you can write, and it says it's okay, it's warning, or it's critical. And that is a sort of rubric that spreads across a whole bunch of tools that are inspired by or descended from Nagios. It's basically, is it alive or how healthy is it? And so there are lots and lots of different ways to do that. Nagios represents kind of one of the first that probably most folks of my generation have used. This ability to do health checks is really important. And actually, Vivid Cortex can do these health checks too, even though it wasn't in that quadrant. There's probably other tools on those quadrants that can do some amount of health checks as well that maybe we didn't put there. But some of the best ones that can do these health checks are Nagios, EDB Postgres Manager does as well. Zabbix is kind of like a newer generation of Nagios that adds in some more general purpose monitoring of metrics and graphing and charting. And then there's Datadog, which is kind of started out in core infrastructure monitoring with metrics and checks and things, and has expanded into a whole portfolio. And then you can take lots and lots of other tools and see that they have some of these functionalities as well. For example, we'll talk a little bit later about application performance management. New Relic is a kind of leading tool in that category, and of course it can do these health checks as well. So basically all of the tools can, but this is a representative sampling of some of those. So let's head on to the next category, which is query performance. And this is really what Vivid Cortex is kind of centered on, although it does other things as well. What we're trying to do with these tools is to understand that workload. The database exists, as I said earlier, to do useful work for the user. And so one of the most important things that we should monitor, therefore, in the database is, how's that work getting done? How's it going, database? I'm asking you to do some work. What work are you doing? What categories? Which is the most frequent? Which is the most time consuming? Which ones have high latency, low latency, all of those kinds of things. So really understanding the totality, the population of queries that the database is executing. And if you're from the Oracle background, maybe queries means something specific to you. And so maybe we should say DML or statements or transactions, but it's basically, it's requests. All of those different types of requests, whether it is getting data out of the database or inserting or updating or whatever it is. What's the totality of all of those requests that the users and applications are sending to the database? And so that, if you put it all together, is the workload, and understanding kind of very solidly focused on the database. What is everything that the database is doing? Because databases might be serving multiple applications, and one of those applications queries might be interacting with another one. So we can't look at it specifically from one user or one application. We have to really see the totality of everything that the database is doing, including background activity like vacuuming and backups and things like that, to really understand what work is it doing, how is all that work interacting, and what's the resulting performance or diagnosis of performance problems. So we've got Vivid Cortex, we've got EDB Postgres Enterprise Manager there as well. A couple of tools that are a little bit lighter weight, PG Analyze and PG Badger. PG Analyze looks at some of the internal statistics tables of Postgres. Mostly PG Badger mostly looks at log files and analyzes the query log and tells you things like what were the most time consuming and frequent queries. All of those in the first orange bulleted list with those first 4 products can do some aspects of this, what queries are my database running. You can also, as I mentioned earlier, you can use application performance monitoring tools or application performance management sometimes, APM. Leading solutions there are New Relic, AppDynamics, Dynatrace, Datadog. There's others. It's a pretty broad category, so there's probably another half a dozen that we could have added to that list, but these are some of the category leaders. And these look at it from the application's point of view. However, since they're instrumenting the application, they also see the queries that the application sends out to the database or to the cache or to other services or whatever. They're seeing the outbound request that an application is making, which includes the database. And a lot of times that'll get you pretty far. If your database is mostly single purpose to a single application, for example, it doesn't have multiple applications using it, then looking in the APM tool, you can often see something closely approximating the workload that the database is serving, but there's a gap. And that's where I've got this asterisk and the very teeny tiny orange font on the bottom. Looking at it from the app-centric point of view, first of all, you have a visibility gap where you don't see what I like to call out-of-band traffic. For example, the database administrator connects with PEM, let's say, and runs some queries. Well, those queries are things that the APM tool isn't going to see because they didn't come from the application code that it instruments, or the backup runs or something like that. And so this gap often manifests as some out-of-band traffic, some noisy neighbor, something unexpected internally in the database, like vacuum running or something like that. And so in the APM tool, what we find a lot in Vivid Cortex's customer base is people will go, I've got New Relic, and occasionally I will follow a stack trace in, from a Ruby controller all the way to the bottom, and I'll see that there was like a 10-second query there in a slow transaction. And it's a query that touches one row. What's the deal with that? Why would a query touching one row take 10 seconds? And there's really no explanation for that from the app's point of view. So you can't use the app's point of view to diagnose the database. And that's why it's really helpful to have the first 4 tools up on top that have the database perspective and can tell you, oh yeah, that's when, the whole database was locked for 10 seconds because of a backup getting kicked off. So hopefully I've covered that well enough. Happy to answer any questions, and we'll have time for taking questions later. But this is, always an area of active conversation. In the meantime, we can go on to the reporting and administration tools. And these are mostly focused on folks who are doing something kind of adjacent or additional to the application. So we're doing things like we're actually creating databases, we're creating tables, or giving somebody access. It's more operational tasks. Or it could be, we're querying, we're trying to run a regular report or trying to develop a report or something like that. For example, just here at Vivid Cortex, fairly frequently we have questions that we didn't anticipate about, how many of our customers have a feature enabled or something like that. And we have to go and look in the database to figure that out, right? So, those kinds of things require more ad hoc tools like a workbench tool or an administrative tool. And I've listed a few of them on here. I've had some experience with all or most of these. And then there's actually a really, really long list of these. Of course, there's PSQL, the ultimate tool, so you could just start up from the command line. But the wiki on the bottom has a really long list of these tools. So it's a rich category. And then our last category is these general purpose monitoring tools. And these are like the data dogs of the world. Historically, it would be RRD tool and MRTG. Graphite was kind of the next generation after that, basically a better RRD tool. And now we have a whole new generation of software as a service solutions. On this list, Datadog, Wavefront, SignalFX, those are software as a service solutions, as is Vivid Cortex for that matter. But those are like the new generation where folks are really trusting others to run their monitoring tools for them for a variety of reasons. And then we've got popular open source tools as well, like Prometheus, which kind of was inspired by Google, the way that Google does monitoring internally, and then spun off of a company that developed kind of a similar monitoring approach and spun it out into open source with Prometheus, and then Grafana on top of that as a dashboard. So there's a lot of tools that can collect metrics, traces, things like that, and visualize them, turn them into graphs. The standard sort of page full of charts and graphs. Behind all of those is usually a time series database like RRD tool. And the capabilities that they add in addition to the graphing and charting is usually there's a way to, for example, set a threshold on a metric and send an alert when it goes over that threshold. These are really good when you want to take a least common denominator approach and get as much of your systems monitored in as few tools as possible. And so, of course, every one of these has a plugin for Postgres where it can connect to the database and query the internal status counters, and then you can draw graphs of those and things like that. However, that least common denominator does have some limitations. For example, you're not going to get a top queries report if all you have is metrics, right? So figuring out which queries are the most frequent and what is their explain plan and things like that. You can't store that type of information in Prometheus, for example. And that's why we need, in addition, most folks, at least when they get to any level of criticality, they also need something specialized for the database and not solely general purpose. All right, so I think we have time for another quick survey, and then we'll continue from there.
Great, thank you. I am going to select our next survey and launch it for the group. Okay, which open source databases do you use? And you can select any that apply. So I'm going to give everyone some time to select.
You can select multiple as well.
Correct. And when I close it out, there's actually a feature where I can share the results with the group. So I will do that this time. Okay, looks like we have most people. I'm gonna close that out, and then there are our results.
Interesting, okay. So it looks like, if you just verbalize it, there's a lot of people using MySQL. Is that, or Postgres, sorry, most people on this call are Postgres, and there are a lot of people using MySQL, and then AWS after that, looks like. Okay, very interesting, cool, thank you for that. So here, we got a few slides on our respective products just to give you a background on what they are and then decide for yourself whether they're for you or not. Here's a little bit about Postgres Enterprise Manager, which we affectionately call PEM, left and right. So, and as you could probably tell from the slides that were presented that Darren talked about, you saw Postgres Enterprise Manager in a couple of different places, and that's because it's a little bit of an all-purpose tool primarily intended for the database administrator. It's mostly along the lines of being able to do alerting and administrative type tasks. It has some degree of tuning capability. It has some degree of being able to understand those, analyze the SQL statements, but it's not going to be able to very quickly identify what the top queries, etc. And I just want to say that it works with both Postgres SQL, the community product, as well as with our proprietary EDB Postgres Advanced Server. And it's included as part of a package of tools from Enterprise DB, which offer high availability disaster recovery, as well as foreign data wrappers, etc. And then, just really quickly in terms of highlights, which I mentioned on earlier, is that it does some degree of being able to profile workloads. It has a really nice, rich dashboard and charts, so you can use a GUI to be able to manage multiple Postgres databases, whether those are community, that's out of the box open source Postgres, or even our advanced server database option. And lastly, we're highlighting the alerts, so you can get alerts, via email, via SNMP, and other monitoring tools such as Nagios. And then let's have a little bit now about Vivid Cortex.
Sure, yep. And so just obviously I'm the founder and CTO of Vivid Cortex, so I have my perspective on this as well. Vivid Cortex is a fully managed hosted solution for monitoring query performance, as well as capturing things from the operating system and the internals of the database. So the kind of the quickest synopsis of that is that what our customers get from us is this complete rich visibility into database performance, behavior, the workload for everybody, not just for DBAs and operations, but also it's very developer friendly. So the whole engineering team often buys into using Vivid Cortex at large scale without impacting the performance of the databases themselves. So that's kind of a really unique set of characteristics that it's hard to find. So for example, this last phrase of without overhead, we do this without using slow query logs, so we don't fill up your disks, we don't slow down transactions, really, really high resolution visibility into what the database is doing without manipulating things, introducing any single points of failure or other hazards. And to give you an idea of the scale at which Vivid Cortex is often deployed, we're monitoring at really large scale at hundreds and thousands of servers, and visualizing all of those databases working together as a single database for a lot of the apps that you probably have open right now on your laptop computer and on your phone. And you can imagine, how big the back-end data stores for many of those, multi-million or multi-billion user applications are. And that's what we specialize at, measuring all of the data about query workload and performance and internals and operating system performance down to, a second at a time across that many servers. So our customers do this because when you get this, really large distributed systems running across hundreds or thousands of databases, it gets really hard to diagnose issues. Like, why is this one server behaving differently than the other server? Even discovering that there is one server or one cluster of servers behaving differently than another is a really hard big data problem when you get to that level of scale. You can find outliers in the workload. Like, there's a query that usually executes very consistently, but occasionally it's just way out there, really slow. Our customers, and in fact, we do this as well in kind of a DevOps development philosophy. Every time you push a release, you can get comparisons of before and after. How did things act before the release? How do they act after the release? Or when you're troubleshooting an outage, the databases were fine an hour ago and something's not fine now. So let me diff before and after and figure out what's different and what might be the cost there, or rule out that the database is the problem. A lot of times it's the application or the hardware. And because of this, because our customers can do all of this, they don't end up throwing hardware at the problems. In fact, a lot of times, we have customers who have been able to cut their hardware spend by 50% or more. So optimizing cost and getting great customer performance, great user experiences with the appropriate amount of infrastructure cost is one of the benefits that comes. So as I mentioned, measuring every query that executes, drilling down, I'll show you a screenshot in a couple of slides on what that looks like, the sort of the high level from which you would drill down. And all of this really high resolution, second at a time. Like, hiccups often begin very small and then they turn into outages later, and being able to capture things more than every 5 minutes, more than every 1 minute, down to the second is really important. And of course, there's rich sets of dashboards and charts and notebooks and best practice advisors and alerts and things like that. I'm not going to show screenshots. There's a lot of features in the product. So let's go to the next slide and talk about when you would choose Vivid Cortex and when you would choose another one. So first of all, if you are one of these fast-growing technology companies, maybe you have a highly multi-tenant application, like you're a software as a service company yourself and you're serving lots of different clients with different workloads. That's a really common use case that we see when you've got this rich, complex, mixed workload and you're trying to figure out what it's doing and why it's misbehaving. If query performance matters, a lot of our customers have millisecond latency tolerances, and if there's any deviation from that, then some portion of the internet is slow, and that's why they use us, so that they can find those kinds of things. We actually support many database technologies, Postgres as well as others. And if you have, as we do at Vivid Cortex, we have a handful of database technologies powering our backend, and we need to be able to see them all working together as a single data tier. And a lot of our customers select us for that. They also select us because they need something scalable that they don't have to run themselves. And having your monitoring system off-prem is really important when your own systems are out. If your own systems if you've got an internal outage and you're not able to use your monitoring system because it's affected by that outage, that's a big deal. So a lot of our customers select us for those reasons. In DevOps shops in particular, we have these really high-performing technology companies that are able to do a lot with smaller teams of engineers because they involve them in the whole application development lifecycle, all the way through operation and production. Developers are responsible for how their queries run in production. That's not a DBA responsibility, it's the developers. And so they need a tool that is easy for developers to use, which not every tool out there is. You know, some tools are more friendly to DBAs and operations folks and less friendly to developers who are not database specialists. Obviously, at this level of scale, adding a bunch of measurement intrusion to the database is a no-no, and trying to build something that can operate at that scale is very expensive, takes years to do. Ask me how I know. You would choose a different option, you know, one of the other options that we talked about, when you have to have on-prem deployment 100% behind the firewall. Portions of Vivid Cortex are behind the firewall, but not all of it. We just could not give the benefits of Vivid Cortex's shared platform and knowledge of all of our customers' workloads and so forth if it were not a SaaS solution. So there's some benefit in having a SaaS solution that lots of customers are using. If you only need basic health checks and query performance is not a concern, you don't need to be able to isolate, you know, what was that one slow query that ran at 2:30 in the morning and why, and what else was running on the database and all of the other databases. Then you might not need us. We're not free, so if you prefer free tools, then you might choose something free. And you wouldn't choose us if you want a management or administration tool, because one of our principles is, look, don't touch. You know, you cannot use us to shut down and restart or reconfigure a database server. That's not what we do. You know, the trust and safety is really important for us with our customers. And so we're looking but not touching. So if you need something that can manage and administer your tools, your databases, you need different tools. All right, on this slide, got a screenshot of one of our features called the profiler, and I've selected a couple of areas on here to highlight some of what's going on. If you look at the top, in the top left, there's a white box that says filter hosts, and then it shows that on this screen is being shown 1,001 of 1,001 servers. So this is actually taken from a screenshot that a customer sent us. This is one of those customers that's running at some level of scale. And even at this level of scale, this is an interactive product. You know, you can switch and read, slice and dice and drill down and everything basically as fast as you can click the mouse. So it becomes very iterative and exploratory. So you're not, you know, waiting for analysis jobs to run to tell you which queries are the most frequent and time consuming and things like that. This is showing a list of the most time-consuming queries across all of these 1,001 servers. And from here, you can click into those, you can drill down, and you can, you know, click and drag on any of the charts and zoom into the peaks and valleys and things like that. It's very interactive and exploratory. The best way to see and understand that is to get a demo, and, you know, happy to jump on with anybody. Our sales team and sales engineering team is always happy to give demos, of course. All we can show here is a static screenshot. So that's all I've got on Vivid Cortex. And I think we've got some resources that hopefully folks will find helpful. There's an earlier Enterprise DB webinar from Bruce Momjian about exploring the rich landscape of tools beyond even monitoring tools, you know, a whole bunch of the different things that you can use to help you in your Postgres needs. On the bottom, optimizing database performance is the slideshow that I talked about earlier, and that is also recorded. So you can both click through the slides and you can watch the video of that. That explains my performance methodology that I've borrowed and adapted to suit lots of folks' purpose. And then a few books. There's Site Reliability Engineering and Database Reliability Engineering, which is the philosophy that a lot of folks are adopting. Originally came out of Google. Site Reliability Engineering is a free book that Google has published online, although you can also buy a paper copy of it. Database Reliability Engineering is really leading work from a couple of the like current generation's brightest minds in database operations and how to make databases reliable and fast at scale. That's Lane Chamble and Charity Majors. Some years ago, I wrote High Performance MySQL, which is specific to MySQL, but I would say is the previous generation of thought process to this, you know, more recent, like very quantitative, budget-oriented database reliability engineering mindset. And then on the right, if you're interested in that full life cycle, everybody's got their elbows in the database and developers own their production performance of their queries. There's a free ebook called DevOps for the Database that I wrote a little bit earlier this year. It's been really, really popular, many thousands of downloads, and I've gotten a tremendous amount of positive feedback. In fact, I've already got enough notes accumulated that I'll hopefully be able to refresh that at some point and expand it. But it's about 65 pages of really meaty technical resources, including tons and tons of links to where other folks have given talks or have blogged about, how they actually get developers involved in the full life cycle. And I wrote that because I think it's a pattern of success that we see in the customer base at Vivid Cortex. The companies that adopt DevOps beyond just sort of configuration and into developers really being involved in and participating in running the databases, those engineering teams just sail ahead of their competition. It's amazing to watch. So this is kind of a compendium of lots and lots of stories about how they do it, what worked and what didn't, that hopefully everybody is interested in. I think that's all the slides that we've got. So we've got links here to a free download of PEM, and you can start a free trial of Vivid Cortex. You can install a substantial number of servers for a couple of weeks and kick the tires on the product. I'm also happy, as I mentioned, to give you a demo, and we'll offer to do that as you do a trial. So some further steps if you're interested in either of these. And I guess we'll break for questions, but before we do, I want to say you can feel free to reach out to me personally. It's not a nuisance. It really brightens my day when people send me an email and whatever I can help with. But I happened to notice something that escaped until I saw the first slide with my contact information. It actually has a typo in my email address. It's baron@vividcortex.com, but there's only one R. So if you get a bounce back, try again with one R, and we'll fix that.
My apologies, Baron. Thank you for that sense of humor there. Thank you. I fixed it on the final rendition.
Okay, great.
Hey, Courtney, with having said that, yeah, so I'll fix that on the first slide. Courtney, please open it up for questions at this point.
Sure. Thank you very much, Bhavani and Baron. Let me open up our question panel, and people feel free to drop your questions in. Looks like our first question is, does PEM work with AWS RDS?
Of course, it does not right now. Postgres Enterprise Manager works with either the EDB Postgres Advanced Server or with the community version of Postgres itself. You can, if you wanted to install Postgres SQL on a AWS EC2 instance, you could use PEM that way, but not directly with RDS.
Okay.
And they didn't ask, but I'll just add that Vivid Cortex works with RDS and Aurora.
Okay. So we have another question that just came in. How many weeks is the trial for Vivid Cortex?
That's a 2-week trial.
Another question that came in for you, Baron. How does Vivid Cortex collect the data from the databases?
That's a great question. When we say, we can do it with this, people are like, how do you do that? So we can collect in a variety of ways. The first way that we prefer is packet sniffing. So there's an agent that runs on the database and looks at the network interface and taps into the kernel, gets the network packets, and then just reverse engineers the Postgres protocol. And so we see every query that arrives, and we see when it completes and starts sending back to the client, and we can time it. We can see protocol flags, error codes, all kinds of stuff. So a really, really rich source of information. We also connect to the database and inspect, the internal status views and things like that, and we look at the proc file system on the operating system and so forth. Other ways that we can capture the query workload, if, for example, you've got encrypted connections, well, we can't sniff that because it's encrypted, but we can look at pgstat statements, we can look at the slow query log file. There's a bunch of different ways that we can get that information. But the really low overhead, really high fidelity way to do that is with packet sniffing. It's magical.
I'd like to add to that, even though it wasn't asked specifically about Postgres Enterprise Manager. So PEM, you get the full fidelity of the product by being able to use an agent with it that is installed either on the same machine or an agent that actually connects to that database. But you don't need to necessarily have the agent to get information on the database. You just don't get the same amount of degree and depth of, say, information regarding the operating system, the disk utilization, all that kind of information. So that's a different perspective, but from PEM, that's all.
Okay. Looks like we have a few questions that came in all along similar lines, sort of wondering what databases can Vivid Cortex monitor?
Okay, sure. Well, obviously Postgres, and actually EDB Postgres advanced as well. Advanced server, yep, thank you. Struggling for that. Redis, MySQL, MongoDB, and all of the variants of, RDS, Aurora, self-managed, hosted, all of those kinds of things. So we focus on open source databases at the moment. And so what does that exclude? Well, at the moment, that excludes like Oracle and SQL Server and some of the other more traditional databases. That may change in the future, but that's where we are today.
And I'd like to just add that Vivid Cortex is a SaaS offering, and I don't want to clearly. I just want to say that Postgres Enterprise Manager it's an install product. So I don't want to differentiate. I don't want to create differentiation, but I just want to tell you what where the products sit in terms of their deployment options.
It's a great point to bring up. You run and manage and administer PEM yourself, and that means you have a lot of flexibility and control over how you do that. With Vivid Cortex, the only thing that you run is an agent, either on or near the database, and then we host all of the metrics, we do all of the big time series analysis on the back end, we keep it available, et cetera, et cetera. Everything except for the agent, which is this small binary written in Golang, runs in our infrastructure.
Okay, great. It looks like we might have time for one more question. So this is a question for both of you. What is the maximum number of databases that Postgres Enterprise Manager can monitor? And then what about Vivid Cortex?
So I'll take that first. This is Bhavani from Enterprise DB. The number of databases, we have customers running up to 500 database servers, managing that using Postgres Enterprise Manager. So that would probably be closer to the higher end of our limit. Baron?
Yeah, we have customers monitoring thousands and thousands of database servers, and we've tested internally much larger than that. None of our customers has pushed us past, what we've tested internally. We try and make sure that our internal testing is significantly beyond that. So it's designed for theoretically unlimited scale, but as somebody who has built and run a lot of really large scale applications, of course, whenever you 10x things, you discover that there's something that didn't quite scale. But we don't see any ceiling on the scalability that has affected any of our customers to date. So bring us what you've got. How many servers do you have?
Okay, great. Thank you both for your time and for answering those questions today. I apologize for those questions that we were unable to get to today, but that's all the time we have. We will be sure to follow up with each of you personally to answer those questions after this broadcast. Thank you for joining us. As a reminder, we'll also be sharing the recording along with the slides via email to you as soon as possible. And I hope you all have a great rest of your day. Thank you.
Thank you.